The student oxidises a solution of hydrochloric acid with a few drops of sodium chlorate 1 solution. The reaction mixture effervesced and turned pale green. The gas formed bleached universal indicator paper. So again, it's screaming at us that we've got chlorine here. Write a half equation for the oxidation of chloride ions. So chloride ions form chlorine and an electron, so that needs balancing. So 2 there and 2 here. Half equation for the reduction of chlorate 1 ions. So chlorate means that it is chlorine with oxygen and it has a positive the chlorate 1 means that this is a +1. That's going to be a -2, which means that this is going to be a 1- there. So that's our chloride. That's the formula for our chlorate 1 ion. Okay, so write a half equation for the reduction of chlorate 1 ions into chlorine. So let's turn that into chlorine. This needs balancing, so I'm going to put a 2 in front of there. And now I'm going to balance this as a kind of redox half equation. So I'll start with the oxygens. I've got 2 oxygens on the left, which means I need 2 waters on the right. That balances the oxygens. I've added hydrogen, so I now need hydrogen ions on the left. There's 4 hydrogens on the right, so I need 4 H pluses on the left. I now balance the charges. So this side is neutral, which means overall this side needs to be neutral as well. I've got 4 plus and 2 1 minuses, so that's overall 2 plus, which means the addition of 2 negative electrons will make both sides there neutral. So write an overall equation for the chlorate 1 ions with hydrochloric acid. So I can either combine these 2 half equations, or in the notes that there's an equation that you can kind of just know if you wish. So what I'll do is I'll balance these, and then that way we can see what we're doing. So remember, when we're balancing these, we've got to balance it with the electrons. I've got 2 electrons being given away in A and 2 electrons being accepted in B. So I don't need to do anything with that really, just combine the 2 equations with everything on the left over here. So 2Cl- plus 2ClO- plus 4H+, and of course the electrons will cancel out. And then on the right hand side, I'll have 2Cl2. I won't have 2Cl2, I'll just have Cl2. Oh yeah, 2Cl2 because I'm adding the 2 together, plus 2H2O. Now that will simplify, so if I can get rid of that will become a 2. And get rid of that and that. You would need to simplify this. Now the alternative is these H pluses here could actually go there and here. So an alternative for this as an answer would be HCl plus HClO gives Cl2 and H2O. And that's the one in the kind of notes that you'll be more familiar with. D, a solution of sodium chlorate 1 was added to a colourless solution of potassium iodide. Suggest what is observed and explain the reaction that leads to this observation. Well, if chlorate will oxidise chloride, it will oxidise iodide. So let's jot down that ClO3 minus will oxidise I minus. Because it oxidises I minus, therefore iodine is formed, which of course is insoluble because, that's a 2 there in case you couldn't see, this is van der Waals, and of course water is hydrogen bonding. So an iodine is a black solid, black precipitate would be formed. So there's our observation there.